Good afternoon, students. I want to welcome you to another base science class. My name is Mr. Kolawole Abayomi Kayode. Today, we want to look at simple machine 2. Last week, we started simple machine 1. Today, we want to look at simple machine 2. The first thing you have to do, you have to look at the correction of the last assignment. Let's look at the correction of the last assignment. Let's look at question number 1 that says, what is a machine? Machine is a device or instrument that allow work to be done easier. That is, it makes work very easy to do. That is simple. That is answer to that one. Then question number 2, define velocity ratio. What is velocity ratio? The velocity ratio of a machine is the ratio of distance moved by effort to that of load. Don't forget, mechanical advantage is just a ratio of load to effort, but velocity ratio is the ratio of distance moved by effort to that of load. Next question, we have explain the meaning mechanical advantage of machine is 8. Explain the meaning mechanical advantage of machine is 8. It means the ratio of load to effort of the machine is 8. Don't forget, mechanical advantage is just a ratio of load to effort. So if it's 8, it means the ratio of load to effort of that machine is equal to 8. That is the meaning of that one. So let's look at objective for this week work. The first one, at the end of the lesson, students should be able to explain levers, the 3 classes of levers, and also the examples. Also, students should be able to explain pulley system along with example. Next one, students should be able to explain inclined plane and wedge. And lastly, students should be able to explain screw jack, wheel and axle, and also gear. Now, let's start from the word lever. What is a lever? It is one of the simplest machine known. It is of 3 classes. Lever is one of the simplest machine known, and it's of 3 classes, depending on the position of fulcrum, which is the point of pivot, the load, and the effort. There are 3 things here. You have to look at the fulcrum, the load, and the effort. It is the position of each other that will determine the class that that particular lever belongs to. So let's look at the first class lever. In this type of lever, the fulcrum, or the one called pivot, is between the effort and the load. The fulcrum or pivot is always between the effort and the load. Example of first class lever is your plier, your claw hammer, the crowbar, the scissors, and the spencer. They are all examples of first class lever. Now, this is a diagram of first class lever. You have hammer there and you have scissors. Hammer and scissors belongs to first class lever. Belongs to first class lever. Now let's look at second class lever. I told you we determine the class of lever. The class of lever you are talking about depends on the position of the fulcrum, the load, and the effort. Now in the second class lever, the load is in between the effort and the fulcrum. The load is in between the effort and the fulcrum. Examples of that one is wheelbarrow and nutcracker. Wheelbarrow and nutcracker. They are both examples of a second class lever. And this is a diagram of a second class lever. You can see the load there. You can see the fulcrum and you can see the force apply. You can see there all those. That's example of your second class. Your wheelbarrow is example of your second class lever. It's example of second class lever. Then we have what we call the third class lever. The effort is between load and fulcrum. The effort is always between load and fulcrum. Example is forceps, tongs, and forearms. They are examples of third class lever, where you have the effort, which is always between the load and the fulcrum. Example, you can see your tweezers and staple. The one you call stapler, you can see it. You have the effort in between the fulcrum and the load. You have the effort in between the fulcrum and the load. Next class, we are going to what we call the pulley system. The pulley system. Pulley is widely used machine. It is used in construction sites, we have it, to raise or lower heavy loads, either to raise load or to lower the load. We have simple pulley and we have block and tackle pulley system. We have simple one and we have the block and tackle system of pulley. The diagram here, we have the fixed one, we have the fixed pulley, we have the moving pulley, and we have the one that has combined. You can see it is having 2. you can see it's having two. Why this one they're having single? But this one is fixed, it cannot move. Why this one is movable, it can move. You have your load, you have the force. So these are examples of a simple and a block and tackle. This one is normal block and tackle, while this one are simple one. Now we have the inclined plane. The inclined plane. This machine is used to raise heavy loads such as drums of oil up a sloping plank to the high floor. We used to raise load. If you have been to market, you see all these carriers. They used to raise load into lorries. Load drums of palm oil. They want to raise. They raise it. They used to load it to push it into the lorry. It's very slopey, so you can use it to raise load into a drum is inside into a lorry. So it's very well, commonly used. You can see how this demonstration of it. You can see there how the man tried to push that load up the inclined plane into the truck. Try to push it up the inclined plane into the truck. That is an example of an inclined plane. Then we have what we call the wedge. The wedge is used to separate bodies. You can see, to separate bodies which are held together by light force. To separate bodies which are held together by large force, such as in splitting timber. For example, we use axes, we use chisels, and we use knives. All this one, you can use them to cut things into two. You can use to cut things into two. You can use axes to cut your wood into two. Chisel also can be used to cut a particular metal into two, and knives can also be used to cut a particular material into two. They are called wedge. Each of them has its own velocity ratio. It has its own velocity ratio. So axes, chisels, knives, they all belong to the wedge. Another, you can see the diagram of the wedge there. We have we can see how they use axe there. Axe is being used to cut the object, which is our wood. You can see it be applied there to cut the wood into two. Then you can see the force, how the formation of the force there, a kind of V-shaped force that will be formed, because the mouth of the axe is a form of V. So by the time you use it, it created a kind of V shape along your wood or along your materials. You can see that it's the first move on to divide it into two. Now, we want to look at another type of machine, which we call the screw jack. The screw jack is very important. The screw jack. Screw jack can be considered as an inclined plane wrapped round a cylinder. Wrapped round a cylinder. You have a screw jack always have what they call threads. They always have what they call threads. The distance between successful screw thread is called pitch. There is no screw jack without pitch. There is no screw jack without threads. So the distance between two threads is called pitch. There's always gap between the threads. So the distance between the two threads that are close to each other is what we call pitch. All this machine, starting from the lever up to this screw jack, has their own what they call the velocity ratio. You can calculate velocity ratio of each of this machine. You can calculate mechanical advantage of this machine. You can also calculate the efficiency of all this type of a machine. They are very important. We use them virtually every day, and we always do calculation for them. You can, if you look at screw jack here, you will see it. The screw jack, mostly if people that are in a vehicle, if they want to raise vehicle, or they want to remove tire, they can use jack. They can use jack to raise it so that it can lift the body of the vehicle up, so that they can remove the tire and put another one there. Most especially if you have been to organizers, they use jack very well. They use jack. We have the one that is automatic, that you don't need to apply much pressure, and we have the one that is manual, that you have to, sometimes you have a kind of jack that you pump it, a kind of pump that as you are pumping it, it created a pressure that's trying to lift along the thread and along the tube, that now push the try to push the vehicle up so that you can have the space to remove the tire and fix another one. So it's very common. It's very, very common. We can see screw jack in mostly everywhere. Most vehicles always have what we call screw jack. Another one we want to look at is what we call the wheel and axle. The wheel and axle. This machine is used to lift water from deep well or to raise heavy loads such as anchors of ships. At home, some people have well. They don't have a normal distance. They have well, and when they want to fetch water, they use wheel and axle, which is like a roller, and you have the rope that is being roped along that roller. So if you release the axle, if you release your hand, you see the wheel and axle rolling. The smaller one is your axle, while the bigger one is your wheel. You see it rolling, and as it's rolling, it depends on the direction. If it's rolled clockwise, it means you want to draw the water up. You want to draw water from the well up. If it's now rolled anti-clockwise, it means you are returning the bucket back into the well. The bucket, you see the rope being attached to the bucket, and the bucket connected to the wheel and axle. So once you roll it anti-clockwise, it means you want the bucket to move down into the well. It's very important. And also, people, if you have been to where they always park ship, you have anchor, which they use to hold the ship. Is that the case? It works also on wheel and axle. By the time it rolls itself anti-clockwise, it allowed the ship to move back. It created more space. It reduces the chain so that the ship can move back. If it now moves clockwise, it tries to bring the ship closer to itself. It tries to bring the ship closer to itself. It helps so that to anchor to make sure it holds the ship so that it will not be moving from one place to another. So wheel and axle is also an important type of a machine that is normally that we can use very well, both at home and in other places. Then if you look at the diagram for wheel and axle, you have diagram for wheel and axle. If you check your door, you see some people that use this type of this type of material at their door to open the door. Some use this handle, but if you look at it, the handle is made up of wheel and axle. If you turn it, look at direction. Once you turn it like in this direction, is that the case? It rotates like move like this. Once it's complete rotation, the axle will rotate half the rotation of the wheel. Please let me say it again. The axle, which this one is going to rotate half the rotation of the wheel. If the wheel should rotate twice, the axle will only rotate once. The wheel is if the wheel should rotate once, the axle has to rotate twice because the axle is very small to the wheel. So what I'm saying that if the wheel should rotate once, the axle will rotate twice because it will take two times of its own rotation to cover one of the wheel because the wheel is having bigger diameter than the axle. That is why you see it like that. And you have some doors that have the handle that's made of wheel and axle. They use it in mostly hotels and in some homes also they use it and it works it's very, very important. It works very well. Then another we use it, we have what we call the gear wheel. The gear wheel also, we have it in cars. We have cars that use gear wheel, bicycles, and cranes. They use gear wheel. Gear wheel is also an important machine which is used every day in cars, in bicycles, and in cranes. It also applies the principle of a wheel and axle. Gear wheel also applies the principle of what? Wheel and axle. Because it's wheel, it has axle or small axle also. So we use it also very well. We use it very, very well also at home and in other places. You can see the diagram of wheel and axle. You can see, look at this one, look at this one. This one is bigger to this one. This is wheel, this is axle. All of them combine together to form a gear system. If you form a gear system, it helps in changing the movement, the speed of the car. The gear system helps So the jet stem also has wheel and axle. As it's moving, it's rotating, it's able to change the velocity or the speed of the vehicle. So it works. The gear wheel also works on the principle of a wheel and axle, which is also very, very important. Then there's what they call a frictional force in machine. Frictional force in machine. What is frictional force? Frictional force in a machine is the force which tends to oppose the motion of one part over another. It opposes the motion of one part over another. That is, it disallows the ease movement of one part of a machine over another. It does not allow machine parts to move over one another. It tends to discourage it. That's what we call friction. That is, in last class, we said that the efficiency of machine can never be equal to 100%, simply because of friction. Friction. That is why the efficiency of any machine can never be 100 because of friction. Because of friction. Then how can we reduce friction? What are the ways by which we can use to reduce friction? We have friction in solid and we have friction in liquid also, which is what we call viscosity. Now, in solid, frictional force can be reduced using the following. We can use lubricants like oil, grease, air, and graphite. All this one can be used to reduce friction in machine. That's why you see some engineers, they always have grease, machine grease, which they apply to the machine so that it will reduce the friction, so that the machine will be able to work on each other. Then we have what they call the use of ball roller, the ball or roller bearing. That one looks like ball, but somehow heavy. It rotates, it moves in between machine so that it allows the parts to move on top of each other. It allows the parts to move on top of each other. It's a roller or board. It allows the part to move. And we also have polymer. We have polymer also. We use polymer in industries to reduce friction. We use polymer also in industries to reduce friction. You can see how one of the reducing agents for friction, which is a polymer. Polymer is one of the reducing agents to reduce frictional force. So it's honestly in between machines. It's mostly used in industries, in between machines, so that each of the parts can roll on top of each other. They can move easily on top of each other, which is very, very important. Now, let's round up by looking at what we have studied so far. In conclusion, in the course of the lesson, we have been able to understand various classes of lever. We said we have first class lever, we have second class, we have third class, based on the position of the load, the fulcrum, and the effort. It is those three factors that determine the types of lever. We also look at pulley system. We said we have single pulley, we have the block and tackle pulley also. We have those ones that are fixed. We have those which pulley are movable. So also we started to look at an inclined plane, which we use to raise load into lorries. We use to raise load into lorries. Also, we look at wedge, which is a machine which we use to split material into two. Your axe, your knife, they all belong to wedge. We can use them to cut material into two. And lastly, we look at frictional force. The frictional, we try to define frictional force, and we define it as force that oppose the motion of parts of machine on one another. They disallow the movement they do not allow ease movement of parts of machine over one another. And we look at various ways by which we can also reduce friction. We talk of ball bearing, we talk of application of grease, oil. Also, we talk of polymer, which is used industrially, or to reduce friction. Now, assignment. The first assignment is that describe first class lever with two examples. Don't forget, we talk on levers. We mentioned the first class. We have example there. Also, describe the top class, which I told you, which you have defined in the class, define top class lever, and also give 2 examples of top class lever. Then define frictional force. Frictional force is an important force which you cannot just overlook like that. Define frictional force and mention one way of reducing it. One way of reducing frictional force. I told you we have frictional force that occur in solid. We have those ones that also occur that occurs also in liquid. Now, for our further reading, we can check STEM Basic Science book. Is that chapter 14? It's made for the book made by the science teachers. Is where we can use it. Then we have Basic Science Made Easy for GS2 by F.I. Kende. That one is very important, chapter 9. Also, you can lay your hands on Essential Physics by Anyakoa, which is very okay. It's also good for further reading, which can help you in and to brush you up in the course of knowing more about the topic. So until next class, when we meet, I say goodbye and God bless.